let's look at my point here. The rate for most reactions constantly changes. All right, except at the end when it's 0. Okay, that's where we reach that limit. Okay, but the rate for most reaction is constantly changing. So over our period of reaction, we're going to see a change in concentration, as I mentioned before. Okay, the rate at any point in time is calculated by taking the slope of the tangent to the production or consumption curves. Okay, so we look here, concentration, time, right? That's our reaction rates. We're looking at concentration over time. We can find our rate either at one particular point, or we can find our rate over a particular time. Okay, there's two different ways that we can find these different things. Okay, so let's talk about the first one, the initial rate. All right, so the initial rate is basically at a given point, we're going to find our rate. And remember, our rate is concentration over time. Our rate's always going to be the same. You have to have a concentration over time. Now, if we're looking for just that initial rate, right, that specific point, for instance, let's say that we're trying to find the initial rate of this point right here in this instance. You're going to take your concentration. So in this case, at this point, the concentration is 0.14 molar, right? Concentration. And at this time, we're at 10 seconds. So how are we going to find the rate? We're going to have to take our 0.14 molar and divide that by 10 seconds. Okay, so once we divide our concentration by our time, we now have our rate, right? Because our rate is always concentration over time. So when we do this, we found that the initial rate, right at the 10-second mark for this particular reaction is 0.014 molar over seconds. All right, that's my initial rate. What if, right, we're trying to figure out our rate over a specific time? How are we going to do that? How are we going to do that? Okay, so in this case, we'll have to use what we call our little tangent method over here. Basically, to find a rate, do the same thing we did over here, right? We'll do the concentration divided by the time. All right, that's what we're doing here. But notice, right, the tangent method, this is the technical term for it. But notice what this is, delta. This delta here. Now, this is key. Delta concentration and delta time is different, right, from just our initial rate. If y'all remember, the delta stands for a change. So basically, if I wanted to find my rate from this point to this point, how am I going to necessarily do that, right? Well, if you remember, delta is final minus initial, right? So I'm going to take my final concentration and my initial concentration and subtract those, right? Same thing with the time. I'm going to take my final time and subtract that from my initial time. And that's what's going to give me my change in concentration and my change in time, right? But the rate is still the same. It's still going to always be concentration over time, right? So, for instance, right, let's say that we're trying to find the rate for this period of time here. This is around 0.5, and then we have around what was that, 3.4 or something like that, right? So basically, we're going to take that concentration right here and then subtract my final minus my initial. So in this case, I'm going to get 0.16, right? Depending on how you estimate it. That's how I estimate it here. So I get my 0.16, and then my time here for 20 seconds is going to be 0.5, 50 seconds. Y'all look at me. Look at the axis. Always look at your axis. So 50 seconds minus 30 seconds, right? And that's going to give me 20 seconds. So that's where the 20 comes from. All right, so that's all we're doing here. All right, so once we figure out our concentration and our time, then we just have to divide to find the rate. In this case, it's going to be at 0.008 molar over second here for this time. frame. Now this is called what we call the average rate. All right, so this is the average rate over time. This is what we would call this. Okay. And this is basically what we did over here, right? This is what we did over here. The rate equals my final concentration. So for instance, if I was looking for the concentration of hydrogen, all right, so my rate, and then notice there's a negative sign. There's a negative sign for these rates in our equation. We're going to do a final minus initial, bam, then final time minus initial time, bam. And then that's going to give me my rate over here, that delta. So that's where we see this delta, that change. You can actually find the rate for one of your reactants or products, and that rate will be the same for all of them, okay? Now the reason being, right, is math, of course. Math is not going away. So A plus B gives me C and D. Now this little a in the front, of course, is going to be our moles, right? So just think of those as moles. And then we can relate this to this equation here, is that our moles is going to be 1 over A times our change in concentration and our change in time. Okay, and this will be able to be equal to all of these, right? They're going to be the same thing. Okay, because if you find one, you can basically do the math to find the other ones. All right.